trends in periodic table. Let's see another periodic property, that is electron affinity. Electron affinity is defined as the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Its unit is electron volt. Energy is denoted always with a negative sign as energy is lost. Periodic table, as we move from left to right in a period, the electron affinity goes on increasing. As nuclear attraction increases across a period, the nucleus of an atom readily accepts electrons which are negatively charged. And so, across a period, electron affinity increases. If we go down a group from top to bottom, electron affinity goes on decreasing. As nuclear force of attraction decreases, the electrons are not attracted towards the nucleus so readily. So, electron affinity decreases down the group. The factors affecting electron affinity are nuclear charge and number of shell. As the nuclear charge increases, electron affinity also increases. As the number of shells increases, electron affinity decreases. As we have learned, down the group, electron affinity goes on decreasing, but there is exception for this case too. In the periodic table, group 2 and group 15 do not follow this trend, whereas group 16 and group 17, in these two groups, the elements belonging to period 2 and period 3 shows exceptional behavior. Like in group 17, electron affinity of fluorine is less than the electron affinity of chlorine, whereas in group 16, electron affinity of oxygen is lower than electron affinity of sulfur. Reason being, the size of fluorine and oxygen atom is very small. As a result, there are strong inter-electronic repulsions, and thus incoming electron does not feel much attraction. Do you know halogens are good oxidizing agent? How? Let's see. Accordingly, across a group, electron affinity increases. Greater the electron affinity, more electronegative the element is, and more will be its oxidizing power. Therefore, halogens are good oxidizing agent. Remember that noble gases has zero electron affinity.